Hello, this is Kim McAllister, and today we're going to look at populations and samples in research. So first of all, we need to understand what a sample is. And a sample is the group of people or things from which data are collected for the study. So they're the people in your research study. So how do you collect samples? What are some of the things you need to know? First of all, you need to be able to select the group of people or the behaviors or whatever that you're looking at. A sampling plan is the way that you're going to do that. So before you begin your study, you have to decide, how am I going to get this information? And so the people that are part of your study, they can be called members or they could be called participants. So there are components of a population. A population can be everybody in the world. It could be everybody who lives in Texas. It could be everybody who lives in North America. It could be everyone who lives in the Northern Hemisphere or the Southern Hemisphere or so on. So our target population is the entire set of people who meet the sampling criteria. The sampling criteria is the requirements in order to be considered for the research study. So when you have determined what your sampling criteria is going to be, in other words, who you want in your study, then the target population is everybody who meets that. The accessible population are the people who are part of the target population that you can access. These are the people that you can pull your sample from. Generalization means how much this sample of people are going to relate to the general population. It also refers to how much of the study that you're going to conduct can be used or expected to benefit the rest of the population. And this is impacted by how carefully the study was done, how it was set up, how carefully the the inclusion criteria were created, and how careful the study was actually done. So some samples of inclusion criteria people could be between the ages of 18 and 45. It could be women with diabetes. It could be women who experience gestational diabetes. It could be people that speak English or people that speak English as their second language. It could be people that were admitted to the hospital for, like it says here, gallbladder surgery, or people who had an MI. We could be looking at people who had an MI and had a second MI, people that were diagnosed with a particular condition in a certain period of time. So just like inclusion criteria means everyone who can be included, exclusion criteria means everyone who cannot be included. And so in certain studies, you might not want to include people with certain illnesses. You might not want to look at children because of the problems with experimenting with children. You might want to exclude any women who are pregnant or breastfeeding, and so it goes. Your sampling criteria is generally considered homogeneous or heterogeneous. And it's homogeneous if people in the group are fairly similar to each other. A benefit of this is that it limits the number of extraneous variables. Extraneous variables are the variations in the sample that the researcher can't control or that they're not really wanting to study. A heterogeneous group would be a more broad group. So when you use a more heterogeneous sample, then you're more likely to have better generalization to the population. If you have inappropriate generalizations, that means that what happened in the study cannot really be applied to the general population. And so you want to be careful in that. A sampling error is the difference between the mean of the population and a mean of the sample. And here you have an example of the population mean, which is right here in the middle. This would be your population. This would be your sample. So you can see in this example, the population is here, whereas the sample is here. And there are a number of reasons for having different errors. And sometimes it can just be because you randomly selected people for the study who were different in some way from the population that you didn't expect. And so these values are not randomly in the population mean. So somehow you ended up randomly getting a group of people that had a high incidence of a certain problem that the rest of the population doesn't have. Or sometimes you end up getting a random sample of people who don't have problems, and that ends up not representing your mean. And I have a really good example of this that I'm going to pull up. Hang on, this is from, alrighty. I don't know if any of you remember the very first inhaled insulin that came out somewhere in the early 2000s. And this was really interesting because the results in the study, when they used this among participants, it was very favorable, and the participants were able to handle the complexity of the inhaler. I don't know if you remember it, but it was about this big, and you had multiple steps. You had to take the capsule out of the pouch. You had to manipulate several parts of the inhaler and pull it apart and open compartments and put it in and push it down and pull it and that kind of thing. And it ended up that people that were trying to use this didn't have the manual dexterity to make it work, and they couldn't handle the complexity. There were a long list of steps that you had to do. And so the sample had a similar manual dexterity to the population, but the population that the study was drawn from had a small number of people with diabetes in the study. And the sample also had little experience working with inhalers. So because of all of this, it ended up making the drug manufacturers think that this was something that was going to be easy for patients to use and would be effective. And it ended up being pulled from the market because it was not accepted by the patients. So this would be a consequence of random samples. So be sure that you know your population. So what is the difference between random and systemic variations? A random variation happens when you have different subjects from the same sample. A systematic variation happens when you select subjects whose measurement values differ in some way from the population. The refusal rate is the percentage of people who don't want to participate in your study. So you have contacted people and said, hey, you get to participate in the study, and they say, no, I'm not going to. And your acceptance rate is the percentage of the people who agree to participate. Your sample attrition happens when people pull out of your study. They may decide they don't want to participate anymore. They may have some kind of change in their health status and they're unable to participate. People also move away, or they get jobs, their schedules change and they can't participate. Sometimes people die. So these are reasons why people would attrition out from the study. Your sample retention is the percentage of people that continue with the study. So random sampling happens when basically anybody in the population can be selected. And so that helps to make the sample more representative. So it improves your chances of generalization. A sampling frame is a list of every single person in the population, everyone that could be included in your study. And so your subjects, the participants in your study, are going to be selected from the sampling frame. A sampling plan is your strategy for how you're going to conduct the study. And it would be either probability or non-probability. So probability is simple random sampling. First of all, simple random sampling means you basically draw names out of a hat. You just randomly pick people. Stratified random sampling is a little bit more complex in that you take people and you divide them into groups, and every element from the population is in each group, and then you randomly select people from the groups, and all of the groups are included in the sample. So if you divide them into 4 groups, you have 10 from group 1 and 10 from group 2, 10 from group 3, and 10 from group 4, and so on. Cluster sampling, again, you're dividing people into groups, but you're only choosing the clusters that work best for you. So let's say you're looking at hospitals across the United States, and so you're going to choose the you're going to cluster them into groups and maybe only sample some of the clusters. So with stratified, you're going to sample all of the groups. With clustered, you're going to select certain groups and sample them. And then systematic sampling is, hang on just a minute. In systematic sampling, you're going to take your total population and divide it by your sample size. So let's say you had 4,000 people in your sample size in your population, and you decided you're going to select a total of 200 people. So you would divide the 4,000 by 200, and then from whatever number you get from that, then you're going to do like every 200th person or every 160th person, every 9th person, and then you make your sample that way. So when you're having a quantitative study, you want to decide how many people are included in your study. And so you want to look at what the effect size is. You also want to look at what type of study you're conducting, how many variables you have, your measurement sensitivity, that's how reliable and valid is your measurement tool. And then it also depends on what type of data analysis that you're using. So in order to determine your effect size, you can conduct a power analysis. Now, a power analysis has certain standards and a level of significance, and those are set. The variation in that is going to be your effect size and your sample size. And so you can conduct that. You don't really need to understand how to do that right now, but generally in your results, you'll see whether or not a power analysis was conducted. Generally, roughly 20% of people will carry one out. Sometimes they'll do that before the study begins, just to be sure that their sample size is correct. If they have a lot of attrition through their study, they may pause the study and then conduct a power analysis to decide if their study is still feasible based on the sample size that they have left. So the effect size is there a difference in the phenomena being studied? It's really how much the sample size, how much the null hypothesis is false. So when you have a larger sample size, you're going to have a larger effect size. And so that will help you determine whether or not a change actually took place. So the number of variables are going to depend on what it is you're studying. And if you add more variables to the study, then you're probably going to need to increase your sample size. And that also will help you have better validity with the study as well. The sensitivity determines whether or not the tool that you're using for the study is reliable and valid. That means it has true positives and true negatives and has fewer false positives and false negatives. You generally are not going to find a tool that's perfect because people vary so much and because people are not perfect. So you want to find a tool that has very good sensitivity. So we're going to talk for just a minute about different data techniques. And generally these are done on computers. You may have heard of SPS software. That's the one that's most commonly used. And so you can use the different analysis to determine what your results are. And the ANOVA test looks at how much variance there is between the two groups in the study. And the t-test is an analysis of two different populations. The chi-square looks at the differences between the frequencies and the observed frequencies. So what was the expected frequency versus what did you actually see? So when you're trying to critically appraise the study sample, you need to be able to tell what was the inclusion criteria, who was the accessible population and the target population, and then look at how generalizable were the results of the study. You want to look at what the criteria were for inclusion and look at how appropriate that was. So how appropriate was the sampling criteria in relation to the study that was carried out? And then you also want to look at what was the sampling method. So in qualitative research, we commonly use non-probability sampling. That means that the sample was not left to chance. And so we have purposive sampling, network, theoretical sampling. With purposive sampling, this is where the investigator deliberately and specifically chooses the people in the sampling. So this is based on the researcher's judgment. The problem with this is that bias can run rampant through this. So you have to be very, very careful when you're doing this to try to exclude bias and really look at deliberately selecting appropriate people. Another type of non-probability sampling is network sampling, and this is better than purposive sampling. With Snowball, you identify maybe one or two people for the study, and then you ask them to identify other people. So it's kind of, okay, come and participate in my study, and then other people that you know with the same issue or with these criteria, invite them to come too. And so then those people that join then turn around and ask. So you may start with one person who invites 3 or 4. Then those 3 or 4 people invite 3 or 4 people, and it gets bigger and bigger. So the size snowballs. Oops. I get excited and use my hands. So what is theoretical sampling? And this is where somebody just goes and gathers information from any individual or anyone who could possibly provide information about this theory. So if you have a theory and you want to get data, and so you begin questioning anyone and everyone who has something related to it. And so you do that until the data is saturated. And you know the data is saturated because you're not getting any new results. No new information is being brought forward. So with qualitative research, we're not going to do a power analysis to determine the size. It's going to depend on other factors like the scope of the study. Also, what kind of topic it is. If it's something looking at a very narrow criteria, a very narrow focus, then you're not going to have very many people participating. It also depends on what kind of data that you want to get and your study design. So you want to look at the sampling, inclusion, and exclusion again and decide if that's appropriate. Is it adequate to address the purpose of the study? And then what are the refusal and what are the mortality rates, the people that drop out and the people that die out of your study? And how is the adequacy determined? So you determine that by Are the sample characteristics and quality described? Was there saturation of the data? Did you really get enough information to fully explain the different concepts in your study? And was the setting clearly defined?